Okay, why don't we go ahead and get started? So, thank you all for coming today for our final webinar of 2025. Today, we're very excited to have Margaret Levenstein back to speak to us today. Maggie is the ICPSR Director and Professor at University of Michigan, as well as the PI for the NSF Infrastructure Project Research Data Ecosystem. Today, she'll be speaking to us about RDE's efforts in modernizing ICPSR's data model and software platform. So without further ado, please take it away, Maggie. Thanks.
Thank you so much, Nicole, and thanks to everybody who's here today. We were just realizing it is getting close to the end of, the semester. It is close to the holidays. So thank you all for joining. It is a small group, so feel free, as far as I'm concerned, to ask questions as we go along. This is obviously, this is work that is dear to our hearts. This is what we have been living and breathing for the last now, well, I was going to say almost 4 years, because that's how long since the project started, but a lot longer than that, since we started working on this. So I could talk forever, and you should just feel free to ask questions. I don't know if I'll actually see the chat. I'll try to kind of keep an eye out in case there are things in there. So I am going to talk about today about lessons from ICPSR's Research Data Ecosystem. That's the name of our mid-scale research infrastructure project, and what we've learned about this, about creating fair data. And for those of you who don't live and breathe this every day, fair is findable, accessible, interoperable, and reusable. It is what we think of as the gold standard for research data. So just to give you a little bit of a roadmap to what I'm going to do today, the first thing I'm going to talk about is, why do we need a modernized research data infrastructure? Why can't it just all be, we got more data than we need, it's all everywhere. Why do I need to do anything, right? So I'm going to talk about why, and then we're going to talk about how we get that modernized research data infrastructure. ICPSR is a 63-year-old data archive. We are the largest social science data archive in the world. So we think we're in a really great position to build this modernized research data infrastructure. But I have to tell you, we have learned a lot about our organization and about how to innovate from the process of building RDE. And so part of what I want to share today is some of the things that we've learned from some of the mistakes we've made, because I think that might be useful to others. Then we'll talk about specifically what RDE is building. And then we'll talk about, I'd say, kind of the fun stuff. How do we continue to innovate building on RDE? And that is, as we're coming to the end of the 4th year of a 5-year project, we're already kind of pivoting and sort of getting ready for what's next. And there's some and again, thinking a lot about the process for how you do that, to make sure that what we're building is really useful for the research data ecosystem, with small RDE. So what are the current user and technical challenges that would lead us to want to take on such a project? As I say, ICPSR is a very large social science data archive. We make data available to thousands of researchers every year, every day. So we have some experience with what the ongoing challenges are. What we know is that people want data, but they don't want to take the time to document and preserve data. Most researchers don't care about that. They want the results of the analysis, and then they want to move on. But poor metadata leaves most data undiscoverable. We actually, previous studies have shown that there are billions of dollars worth of research funds invested in doing scientific research that creates data, and most of it never gets reused because it is not discoverable, it's not accessible to others afterwards. And that means both that we've had an enormous waste of money because we've created all this data and nobody else can use it, And the research that's done is not reproducible, and it's harder, it's less transparent. We all know we have enormous issues with trust in science, and one important way to address that is by making things more transparent, more reproducible. And it also makes it harder to build on science, right? Somebody does something, you want to be able to figure out what's the next step. Some of us are Einsteins, but most of us are going to do incremental research that builds on others, and that requires data accessibility. Poor metadata undermines that, or no metadata, right? So that's the first thing. The second thing is that most data producers want the newest data. They focus on the newest data, and as a result, we lose access to older data and the related documentation that makes it useful. All of this is more challenging with what you might call organic data or found data, digital trace data, because there isn't documentation that's built into the construction of the data itself. So where we are is that secondary data users struggle to find data, and archives struggle with ancient platform technology. At least ICPSR is, I think, what you would call ancient. We are at 63. Most scientific archives, certainly social science archives, are younger than that. Though there are others, there are statistical agencies that certainly have technology that's even older. They deal with broken code. And things like that, which are on the one hand, they're trying to serve all this new cool data and make that available to researchers in a way that is fair, that is reproducible, that is findable, but they're trying to do that with technology that is outdated. So that's our challenge, right? So new technology, it seems like, well, why would you try to build this on top of a 63-year-old platform? And it's not that ICPSR hasn't updated things in 63 years, but why would you could start from scratch. You could have a de novo system. And there's an inclination to do this, but this is one of the things I'm going to emphasize a lot, which will not surprise you, since I'm a social scientist. I'm an economist by training. Is that it is not just about the technology; it's also about the organizations and the relationships, the social relationships that support access and support findability. And when you try to create a new technology from scratch, you don't have that organization. You may have beautiful new code, but you won't have the data, and you won't actually have the relationship to the research community. Every single one of you, and I can't see where you're all sitting, but I have confidence that every single one of you is at an organization that is a member of the ICPSR Consortium. We are embedded in the research community. People come to us for data. When somebody decides, oh, I'm going to invent something new, they don't think about as an economist, they think about production, but not distribution. That's the economist in me talking. They think about, I'm going to have this great thing and the world will come. But in this world that is so crowded with data, if you're not embedded in the research community, people, even if you have a wonderful product, people may have a hard time finding you. So is a challenge if you're trying to start something de novo. It gets rid of some problems, but it causes others. If you do this as we are from an existing archive, you're trying to constantly keep up with changes in software and data, and that means that ICPSR's platform has multiple generations of software and data in different formats, software from literally different decades. And you're trying to this is not the technology part. This is the managing challenging funding environments, which let's just say, thank God we are at the end of 2025. And let's hope that 2026 is better. At the same time, we are serving users who want easy access to data. So that one of the things that you'll see in talking about what we've learned from RDE and from building RDE is that we're very much flying the plane while building it. So we're building new metadata standards, we're building new data ingest, new data dissemination. Well, we're continuing to do all those things every day, and our researchers don't like it when you roll something out and it doesn't work, and there's a, and it, or when there's something new and cool that's available for this data, but it's not yet available for that data. So those are the challenges that we faced. It's also actually, so there's the user side, there's also from the side of our employees. We have about 160 people here at ICPSR. There are some of them who are living inside, working on RD every day, and there are others that are supporting users and trying to have them communicate with one another and have everybody understand where we're going is, again, part of the flying the plane while building it. When the flight attendants tell you to, put on your, to put away your laptop because you're about to land and it turns out you're going to a different airport, it's confusing. So we kind of have to keep everybody on the same page while we're doing this. So we are bringing the technology to where the community is, because where the archive, where the data already are. But that means that we're building the new platform while flying the plane. Okay. Again, this is why would you do this? This was our graphic for a long and winding road for research data. And this is sort of I don't know if you can see all this, but here you have to write a grant proposal and get IRB approval. Again, we're social scientists, so a lot of our data is not about stars, it's about human beings. And that means you have to think about human subjects protection, you have to think about confidentiality protection, you have to consent people, and you have to have data use agreements. If you're a good scientist, you want to pre-register what you're doing. You have a data management plan. Maybe you're scraping some of the data. And metadata, you're not thinking about metadata. You get to the top of the platform and you don't just want to get going. And you do not want to fall over this, into this ditch. A lot of the data that we do, because it's confidential, is restricted data. Then you have to go off into this mountain. Oh, and then you get into your analysis mountain and you think you're so happy, and then you get through and you need to be able to share your data with journals and funders and tell them about what you're doing because they mandate that. And gee, you dropped all that metadata over here when it was, you just tossed it over the side of the road. And so your data ends up, this is a house with an attic that is stuffed full of data that nobody can find. And so it ends up in a graveyard. So yeah, this is an estimate from one study, said $250 billion of data creation and 212 billion of it goes into the graveyard, right? You can't find it, it's not useful. So that's what the ecosystem looks like at large. The platform that we were dealing with here at ICPSR was looked like this, which you don't have to worry about this. This is just a jumble. These are the different ways that people were accessing our system and that we were storing it and curating it and creating reports. And it was a jumble. And we had maps that took up walls and walls and walls. Every time somebody new tried to join the IT team to explain to them how our technology worked. We are moving to something which is simpler, cleaner, easier to manage, more sustainable. It's built on the OAIS reference model, in which the idea is you have data producers, you have an ingest package, and you have a dissemination package, you have an archival package in the middle, and there are certain processes that are standard across every data archive, and we would like our technology to look this clean as well. So our software modernization process, RDE, is addressing these challenges. Or archives, like ICPSR and others, have the data. That's where users are going to look for data. The technology needs to be modernized to make the metadata interoperable to work with larger and more varied data. So researchers may not care about creating metadata at all, but then that's when they're producing data. But then when they want to use new data, and at least in the social sciences these days, it is all about data integration, about bringing data together from different places. and different types of data that are measured at different scales. And that means that you need to have interoperable metadata. People increasingly want AI-driven tools, and we'll talk more about that as we go on. And we are building a unified platform so that it is, as I said, less expensive to maintain into the future. That is one thing. I don't know about everybody here. I know for some of NSF's research, especially its large-scale infrastructure products, it builds them and then it helps to maintain them. In the social sciences, that does not always happen, and so we're very focused on making sure that we build things that are not prohibitive to maintain, even though we know that they're going to need to be updated continuously. So how do you do this? And this is the process matters. So we have this idea that it matters that we're building it where users are, because that's where you have information about users. That's where users are going to go. So we want to build it where the users are. We want to build it where the data is. And we want to build it sustainable. How do we do that? Well, what I would say is key is that we have embedded our software engineers with the user support and the data users. So that's part of what's made possible by doing this in an existing archive. On the other hand, it's just saying that ICPSR hires them, and they don't, and user support and data users don't ordinarily just sit around chatting with software engineers, especially when it's all starting during COVID and everybody's remote and you're trying to get everybody to know each other and to understand what users want. This is incredibly challenging. So we are constantly trying, both with things that are in person and things that are virtual, things that are about work and things that are about fun, to embed the software engineers with the organization that serves the research community so that they understand what the research community is looking for. We have established subject matter experts as key decision makers in collaboration with technology experts. Again, I can't emphasize how important this is. When we designed the project, we said we were going to have software developers and then we were going to have these faculty expert teams. And that's the correct idea. The challenge is making sure that the faculty who are your subject matter experts are involved at a cadence with the people who are doing the software development, and at a level of detail that allows them to be engaged and useful as decision makers without somehow expecting them to be themselves software engineers, because they're not, right? They can't do that. And if they try to do that, you will end up with buggy, not production quality software, or just a stalemate. So what we really need to do is invest time and resources in establishing these connections. And that's what I mean by translation. I have to say, I think every single research project of any interest, I shouldn't say things that are so categorical as that, but today involves translation. All of data science involves translation, bringing together people from fundamentally different backgrounds and helping them to communicate with one another in order to advance science, in order to have people who are economists talk to computer scientists, talk to astronomers, talk to biologists. That's this isn't a metaphor. This is really what we have to do to address the central issues in science today, whether it's climate change, whether it's pandemics, whether it's anything. You need to bring together people who understand, researchers who understand both the technology that you're using for analysis, the way that humans behave, the way that they interact with the biological and physical world, and how that affects both sets of things. So translation is, and reducing the barriers to translation are what you need. That is in particular what you need in a project like this. Technology alone cannot solve the problem. The process for building the technology matters. bringing those people into the process and giving them the confidence to talk to the engineers, and the engineers the confidence to talk to the subject matter experts, so they learn from each other and can co-develop things. So the way that we have done this in RDE is that for every part of the project, we have several stages. What we call a pre-planning stage, a discovery stage, and that discovery stage involves several different, very intentional kinds of learning about user needs, learning about different alternatives for addressing user needs. Then there's strategy and planning and prioritization. Then there's user UI design, and finally development. Obviously, there's development that may happen earlier on, but it is or design that happens earlier on, but it's but you really need to have these iterative phases in which you're thinking through the problems in order to make sure that what's being developed is responsive to the user community. And throughout, you need user input and testing. And again, I have to say, this is one of these things I remember, and I put user input and testing, and we now have, I think Jeanette may have to correct me, 4 different development environments. There's sort of there's the design space, and then there's a development space, and then there's user acceptance testing, and then there's production. We used to have a 5th space. I can't remember even what it was called anymore. But we wanted to make sure that we had lots of different spaces for doing different kinds of testing, and so we built out so many spaces that that some of our engineers were doing nothing but promoting code from one space to another, and that created other kinds of bottlenecks. So these are not fixed rules. These are about how you make it work at the scale for what it is you're building. We have a combination of Scrum and dual track Agile and shape up processes that have allowed us to use Agile, but in a way that is, I have to say, more agile. So there's a structured process with Scrum providing clear role definitions, structured processes to get the work done on a day-to-day basis. And then we have to balance discovery and delivery, where dual track Agile can provide a framework for validating ideas through user research, prototyping, testing, and doing again. But not forever, right? You have to actually get things done, which is, I think, one of the challenges sometimes at that. And then on time and within budget, right? Clearly, NSF cares about this, right? And so do we. And again, both for getting the project done and for building something which is sustainable, we really need to prioritize the core value within our time and budget parameters. So we've actually, and again, we have experimented with different configurations of our software development team. Again, there was sort of what we wrote down in the original proposal, in which there were sort of 2 developers and a DevOps and a UX person and a faculty member. I don't know. Anyway, assigned to each team, and they were each going to develop a product. And that looked really nice on an org chart, and we had great visuals, but it didn't actually work. Because you didn't necessarily have the people with the right skills to working on the right project or communicating with one another. So we have sort of 3 separate teams, a platform team, which we added later on, which is really focused on internal services, our APIs and our libraries, that streamlines the work for the other people who are focused on particular products. And that's what we mean by a stream-aligned team. Then we have complex subsystems teams. One of the things that we have been working really hard on, that I'd say I was really scared about as we started this project, and I continue to be scared about it when it's like our risks, it's always popping up, but it's because of what we've seen in big companies, is that the thing we want interoperable data, but we also want for our users and for sustainability to have our technology itself be interoperable, and that's really challenging. You do that by having a platform team that is providing services to the whole organization, and through a subsystems team that's building things that work with the different products, the different streams of what we're doing. And when they all rely on the same subsystems, they're more coherent and interoperable themselves. So we have teams that handle areas that acquire specialized knowledge or computational complexity. So there's people who are really into doing stuff with AI, they're in one team, right? And they can then make use of that for lots of different products. And then we have our stream-aligned teams that focusing on delivering value aligned with a single product or domain. This transforms that pothole-filled road through the mountains into what we like to call a research data superhighway, in which, of course, you end up at the Elysian Fields at the very end, where it says making data fair in that rainbow. I have to say this was really inspired more by Zumbinis than by Elysian Fields. But the Zumbinis, if you succeed, you get to this wonderful place. And in our world, this is where data is reused and recycled for better science. And each of these products are the different streams of work that we've been doing as part of building as part of the research ecosystem. And they are helping researchers to collect data, to organize their data, to archive and share their data, for other researchers to access the data and analyze it, and then to disseminate their results, right? And that's the model of data production and dissemination that we would like. And there's our beautiful scientific results at the end. So what are the specific benefits of RDE? I've talked a lot about the process. What is it that we're actually doing? Well, the goals are to benefit the research data community, particularly, but not exclusively the social science data community, to discover and use data of different types. So not just the traditional survey data, but lots of other kinds of digital trace data that people are increasingly using in the sciences today. The ability to explore data to determine if it's suitable for use, right? The ability to work with different scales of data and to share data fairly. In order to achieve these goals, we needed to improve data security. Again, so much of our data is about human beings or it's about firms, and all of this is sensitive and confidential. We also need to improve the system's speed, improve mobile device accessibility, improve interoperability across data institutions via APIs, and increase sustainability, both financially and technologically. So those are our goals. And then, we didn't talk about AI in our proposal, but we talked about using machine learning, which we did. And if somebody wants to rename it AI, that's okay with me. We are also quite actively thinking about new ways to use AI to do what we're doing. So what are the core elements of RDE? And what is it that they deliver to the research data ecosystem or the research community? So there is an integrated data lifecycle software platform, right? One platform to support this entire work. That is based on a flexible metadata standard, which we call RDDF. And it's based on architecture facilitating ingest, analysis, curation, preservation, and dissemination of new data types and sizes. And I'll talk more about RDDF in a minute. The researcher passport, which is one source for authenticating and authorizing, which for ICPSR replaces a system where we literally had 20 different ways of authenticating users, depending on how they were entering and what they were doing in the system. Again, this increases sustainability and it makes it possible for us to actually make things secure. The long-term goal of the researcher passport is really to streamline researcher access to confidential data. So TurboCurator is another one of our tools. It automates the production of key metadata using AI and jumpstarts the curation process. So when somebody goes to share data, TurboCurator gives them recommendations to make it easier for them to produce high quality metadata and therefore make it more likely that what they do is useful to other researchers. StatSnap is our online tool for data exploration so that users can explore data before downloading it. And then finally, we have new search functionality. We actually are doing some other things as well. I just realized like Cobra's not on here, but we're not going to talk about that today. Cobra is our cloud-based platform for analyzing restricted data. So we have modernized search technology and a user interface for finding data, which leverages the new metadata standard. So just to kind of give you a little bit more of an idea of how what we're doing maps into the findability goals. We want to, or it's been the fairness goals, the first of which is findability, right? So metadata are assigned, the metadata and the data are assigned a globally unique and persistent identifier. Well, that's true for all data in ICPSR. Data are described with rich metadata. That's true for a lot of data at ICPSR, but it is a very labor-intensive process. And for some data, and in fact, an increasing amount of data, we get stuff without rich metadata. And so we've been using products like TurboCurator to enhance the metadata and automatically assign that DOI to reduce our costs in producing high quality metadata, to be honest. And we're also doing things like in our video data tools project, working on automatically extracting file level technical metadata and in a way that allows us to use that so that researchers can find video or find geospatial data, search for things using what we know about the file types. Metadata clearly and explicitly include the identifier of the data they describe. We do that with TurboCurator, and then StatSnap actually is the way that we disseminate that. And then the metadata are registered or indexed in a searchable resource. Again, I'm going to talk more about search a little bit later, but StatSnap is part of what helps us do that. So what is it that makes our data accessible, that makes it so that researchers, when they find it, can actually get to it? So StatSnap does cool things. It allows you to actually see the first 10 lines of the data and to look at each of the variables to get some basic information about the data without even looking at the documentation about the data itself. It also includes usage statistics so that if you share your data with ICPSR, you can tell whether someone's used it and how much. And if you're looking at a data set, you can see whether others have used it. And in fact, you can also look to see what publications there are from that StatSnap homepage. You can see what other publications there are that have used that data. So TurboCurator and Cobra, I should keep an eye on the time here. Okay, TurboCurator, Cobra, Researcher Passport, all of these are helping to make data more accessible, as does actually the API gateway, which makes it possible for other platforms. You can search for the data on ICPSR, but you can also export the metadata to other platforms that make it searchable and discoverable there. Similarly, what makes it interoperable? TurboCurator, all of these things are helping to standardize the metadata, to provide the standardized metadata in schema that are common to other organizations. We use RDDF ourselves, but actually we heavily rely on other, and I'm going to talk more about this, on standardized, that are community standardized metadata and controlled vocabularies to make the data more interoperable. And when somebody puts data into TurboCurator, the recommendations they get will make it more interoperable. And then finally, reusable. So again, TurboCurator, Cobra, we have persistent storage management, we have technical metadata. All of these things make it easier for people to reuse the data that they find. All right, so and then finally RDDF, which is our improvements. And I have to say this is their improvements to metadata for discoverability, for understanding and context, reuse, interoperability with other catalogs, as I mentioned, long-term preservation, trust, and credibility. Actually, I think this is probably more important today than ever for people to have a sense of that they can figure out what the provenance, the origin of data is, and so they know that they can trust it as high quality, not fake, not distorted, not messed around with data. So RDDF is based on extensive consultation with existing metadata standards, including the Data Documentation Initiative, DDI, which we host, multiple trusted data repositories. We are a core trust seal repository. If any of you are data repositories, and that's the International Science Council's seal of approval for data repositories. We also had to consult our own faculty, our own staff, and then our users. And again, one of the things that made it possible for us to do this is that we have thousands of data users, and so we're in a position to learn from how our users are working with our data today, and that really drove the development of RDDF. Major components that we're really proud of include standardizing metadata from free text fields to widely used controlled vocabularies like DDI, mesh the medical subjects headings, geonames, so that instead of having strings for places, they are actually places on the globe, and the Journal of Economic Literature's classification system, which we use in economics. We also have, wherever possible, shifted to the use of persistent identifiers like ORCID for people and ROAR for organizations, and grant awards for the funders for funding that led to the creation of the data. This is also helps us to do something which is incredibly important to funders to try to understand the impact of the data that they fund, and we can do that. And oftentimes data is created and the grant ends and there's no way to get reporting back. And this actually, using ROARs and grant awards, allows us, and together with the reporting metrics, the usage metrics that we produce, allows us to produce much high quality, fine-grained information for funders about the long-term impact of the data that they finance the production of. The Researcher Passport is kind of my little baby. It is the single sign-on for getting access to ICPSR data, for getting access to restricted data from the federal statistical system. And one of the things I have to say, one quick lesson about this is that we designed this thinking about researchers. Well, we didn't realize we were thinking about researchers at R1 institutions, but we designed it to use single sign-on with In Common, and it turns out that lots and lots of institutions that don't have as much money as R1s use In Common, but only with very limited functionality. And so we rolled this whole thing out, and it meant that smaller schools, they would think that they could use In Common to log in, and it turned out they couldn't. And so we had to redesign it some to do this. And I think this is, again, emphasizes the importance when we're thinking about accessibility of engaging with the user community and bringing in a broad swath of the user community to give you feedback, so that we are inclusive in how we're supporting what we're building, and we can have as many people participating in the scientific enterprise as possible. TurboCurator that I've talked about is a tool that researchers use to share data. They can use it to share data at ICPSR. They can use it to share data at Dataverse, which is a different platform that's based. It was initiated at Harvard University, but there are Dataverse instances around the world. And TurboCurator can be installed on any Dataverse instance. And then when researchers are depositing data, we use it as a workflow that pulls from ChatGPT to enhance, give them recommendations for metadata and generate meaningful research titles, descriptions, and keywords, again, that use controlled vocabularies that are consistent with best practices so that what they do is fairer than it would otherwise have been. StatSnap, which I referred to, here's a StatSnap for from one data set, the voter registration, turnout, and partisanship by county. And you can see it gives you a data preview where you can see the first few lines of the data. You can also look at frequencies and crosstabs, look at the variables in the data, as all before you're actually downloading the data. You can figure out whether it works for you. Does it have the variables you need? Does it have the number of observations? Does it have this range of observations that you need in order to make use of the data? Can you integrate it with other data sets that you might be interested in? And then you can export the metadata or download the data itself. This is public use data, so you can just download it. We also have restricted data that you have to go into that mountain that we're making. It's a friendlier, nicer mountain. We've also rolling out a new search functionality that leverages all of this new metadata, and it leverages both the intentional surveys that we've done and interviews, observations of individual users. We also used digital trace data. Our faculty here at ICPSR used digital trace data from ICPSR's own search. So how is it that people search for data? What is it they follow? And we use that to redesign the search to give people a better user experience. We have 20-some thousand data sets. If you search for something, actually, I guess it says this, as of this slide, we had 21,000 data studies with, hundreds of thousands of files. If, you search for, I don't know, mental health, you're going to get a lot of results. So we want to give people ways of finding things, narrowing things down to what they want, and this does that. So that's what we've been building. And now that we're 4 years in, we need to be thinking about, there's this little AI disruptor. We want to make sure that we're using the most innovative stuff in what we're building now and what we're going to do next. Now that's there is this funny tension at NSF that maybe some of you who are involved in infrastructure projects understand, which is that NSF wants innovation and they want you to always be thinking about how to innovate to produce the best science for the research community. NSF also wanted a 5-year project execution plan, as though we were going to write down everything we did at the beginning. So one of the things that we've had to learn how to do, and I think our team, our incredibly supportive team from NSF has had to learn how to do, is how to work with both of those so that we write down our whole plan and then you update it. And then you focus on what are the basic principles, what are the goals, so that you can actually produce something that's not 5 years out of date by the time you finish. And this was particularly true because of changes in AI that happened during the last 4 years. We've addressed this in a number of ways. This is kind of the fun stuff, right? What we call the ICPSR Innovation Lab. And sometimes that involves students. Sometimes it's students going into classes, having groups of students come into ICPSR. Sometimes that means doctoral dissertation students creating a knowledge graph from our data, or coming in and again looking at digital trace data about how we're working and using that for their dissertations, and then our learning from that. And that's been great. We have collaborations across the university with folks across the social sciences and in computer science and in data science and in the School of Information. We have collaborations across the ecosystem with other data archives, including Dataverse that I already mentioned. GASIS and SICT and the UK Data Archive are all individual archives in Europe, and CESTA is the Consortium of European, or the Council, I think, of European Social Science Data Archives. So we work with them. The one thing I skipped is actually the thing that we did most recently, we started most recently, and which is so much fun, and that is that we had a day-long, it was one day, and it was a hackathon to which we invited everyone in ICPSR. So we've also done hackathons with students, and those I think are kind of more, I don't know, traditional. But this was a hackathon for within ICPSR, and it was voluntary, and we had one day in which we broke everybody up into teams, and they were intentionally cross-disciplinary teams that included both people who were sort of social scientists who work with users and our engineering developers and designers. And they were each given a task related to using AI to address some part of the process of dealing with data that has been contributed to us with very limited metadata. And sometimes these are data which we've gotten the same data set over and over again, and we need to deduplicate it. Sometimes we don't know what the provenance of the data is. Some of it's that we don't have good, documentation. And within a day, we had 6 teams. And each one of those teams had come up with little toys, but they were toys that you could show and tell at the end of the day that actually addressed a concrete problem. I would say most of them, they all looked at using AI to address a concrete problem. Some of them used AI, and some of them said, actually, it turns out that there is a less energy intensive, less, perhaps not a large language model driven approach, but using other kinds of new technologies to try to address their problem. And I loved that because it was not. I mean, there is this tendency, which some of you may have seen, in which, if you have a hammer, everything becomes a nail. And we were trying to tell people, yes, we want you to learn about AI, and yes, we want you to think about how AI can help solve the problem. But remember, the point is to solve the problem and to learn how to work together with other people to solve the problem. And so it was great that they could do that. And each of those sort of experiments, I think, is now going to be the basis for further pilot work and further innovation in the construction of new infrastructure. So how specifically are we using AI in RDE? TurboCurator, as I mentioned, uses AI to inform recommendations to enhance metadata, was originally built for Dataverse. Now we're using TurboCurator at ICPSR. Again, whenever someone deposits to ICPSR, they'll be given the option of using TurboCurator to improve their metadata. We're also working, and I think I have a slide for this in just a second if I have time, on using AI for search. And in case I don't get to, like, a little chat bot that helps you talk to them about your research problem and help you find data. And then doing a lot of work on using AI responsibly and how small language models rather than large language models might be better and less costly for our work at ICPSR. One of the things, what we are not doing is encouraging people to take ICPSR data and dump it into a public large language model. In fact, that's against ICPSR policy because it constitutes data redissemination, which we don't permit, but also because it creates incredible risks to confidentiality protection, even for data that's been de-identified. So this is more about the one-day hackathon, and these were the different challenges that people were involved in. And it was just really fun. This is a little bit about the data chat for search that uses the idea is to increase users' proficiency with using the search system by by interacting with them, and then helping them to find the data that they need. So what have we learned from all of this, right? What I would say is what we've learned is that in order to successfully complete an infrastructure project like this, and in order to successfully build infrastructure that is sustainable, you need to be a learning organization. You have to learn from your mistakes. You have to be curious. You have to think about organization as well as technology. We need to think about both flexible technology and flexible people. One of the things we've always is it's expensive to save money. It is, this is building something which is sustainable, requires investing a lot in things that are more modular than what we had, so that they can stay up to date, that we can continually update things. Flying the plane while building it requires patience and creativity, and it's all worth it. The collaboration across our archives, both within ICPSR and across the research data ecosystem more broadly, could and should save money and give better outcomes. But it takes time, it takes money and commitment, and we're actually, it's kind of exciting to be at this point in the project where you can really see things coming together in a way that really supports the scientific community. So thank you, and I am happy to, do I have a slide that says questions now? I am happy to take your questions.
Okay, great. Well, thank you very much, Maggie, for being here again, and happy holidays to everyone. We'll see you in the new year.
Thank you. Thanks so much, Nicole. Happy New Year, everyone. Happy holidays. Bye.
Take care.